Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with Everest Networks. Today's host is Ryan McKenzie, and he is their North American Director of Sales. He'll be presenting with us today. If anyone has any questions, please be sure to submit them in the question box. Ryan will answer them at the end of today's presentation. Ryan, thank you so much for being with us today and for bringing all of this great and new information. We're looking forward to it. Please take it on over.
Thank you. Thank you very much, Julie. And thank you, everyone, for attending. We appreciate it and look forward to the next few minutes in discussing the Everest Wi-Fi system. Special shout out and thank you to Julie and the team at Microcom. They're a valued partner of ours. And we love to work with their sales team and their marketing team in order to bring this information to you. So this information today is going to be a little bit different. If any of you have attended previous webinars with Everest, we spent a lot of time on technical, we spent a lot of time on engineering, and you know what? I decided that sometimes we need to have a little bit of fun. And so this one I wanted to put a little spin on the Wi-Fi and talk about how Wi-Fi is similar to concert audio. Right now, we happen to have Coachella. If anyone's following the news, Coachella is taking place in California at this time. A hugely popular event. Our Wi-Fi system happens to be deployed there, providing Wi-Fi in some of the VIP areas. And so it inspired me to really do a webinar that I've been wanting to do for a long time, and that is kind of how audio and music is related to Wi-Fi and how Everest really has followed a lot of the same technological advances that audio has taken in order to deliver premium Wi-Fi. Now, first of all, I'd ask a favor of you. Think back to your first concert. Music for human beings is an emotional connection. So if you think back to your first concert, in most cases you were a mid-teenager or early 20s, and it was an environment that the first time you were in was exciting because there was new sounds, new smells, new people, and it was an environment that you craved and wanted to go back to. And in most cases, you can remember that first concert. I remember mine was UB40 with Fine Young Cannibals. Seems like 100 years ago, but it was a fantastic concert, and I remember it to this day. Over time, concerts and music festivals have evolved and changed, and now it's a daily part of our environment. Every year, millions of fans all over the world go to different concerts, different musical events, and we as network engineers are really asked in a lot of cases to come in and help provide connectivity to a lot of these locations. So that's one of the reasons I wanted to take the time to go over this, is because many of you are being asked to provide a solution, and we want to spend some time talking about that. In order to do that, I wanted to set down some ground rules of kind of what every modern day concert has in common with other festivals. That is, every square inch of a venue is packed. If you go to a modern concert nowadays, if you're sitting in seats, you're lucky, because then you might have 4 feet squared that you have kind of to maneuver around in. But if you're in a music festival, it's usually down to 1.5 to 2 feet, 2 square feet in order to move in. In a lot of cases, you've got, in fact, in most cases nowadays, as you can see in the picture, you've got mobile devices. Almost every user has a mobile device that they're using to record, that they're using for social interaction, to post to Instagram, Facebook, etc. And it's interesting that in my time with Panasonic and Everest, one thing that I found is that every time somebody takes a picture, especially with modern day phones, that cloud storage tries to kick in and immediately upload that photo, and it just completely crashes the data networks. And so one thing that most of these locations have in common is standard LTE, the cellular services, data services, and Wi-Fi systems crash under that heavy load and are really not able to provide that connectivity that's needed, not only for the convenience of uploading to social media and downloading information, but for emergency services, wayfinding, things like that. So let's jump in and dive a little bit deeper into what we want to talk about today. So first, I want to take us back and do a little trip to the past. In the early days of rock and roll, concerts were done on a shoestring budget. artists went around and toured in pre-built venues, or really not built for rock concerts, built for other things like county fairs, things like that. And their goal was not to provide a great show, it was really to sell albums. Now, because of that, a lot of times the artists were forced to use the house sound system, like a public address system, a PA system. The first true PA system was developed by Magnavox. This is in the early 1900s, and it used a 34-inch horn to deliver up to 25 watts of audio. So they had one speaker basically per horn, and that covered the entire frequency range. So the entire frequency range from your basses to your mid-range to your treble. That one speaker covered the entire frequency audio range. As concerts became more popular, as we had the British invasion in the US especially, we found a need to have more sound and better sound in order to deliver to larger concert venues. So in 1965, it was actually a landmark moment when the Beatles played at Shea Stadium in New York. They used a cutting-edge audio system that delivered an estimated 80 to 100 decibels of audio, which was really unheard of at the time. The only problem there is it was estimated that the crowd produced more sound than the sound system did, over 135 decibels of audio, which completely overwhelmed the 175 watt amplifiers that the audio system was using. So it provided an environment where not a lot of people could hear because there was so much screaming. Now, we're not going to spend a lot of time on this, but just to give you, some reference, modern day concerts nowadays really target about 115 decibels. And if you think about that in relationship to other things, a normal speaking conversation is usually about 60 dB. A jumbo jet flying over your head at about 100 feet is about 110 dB, just to give you some idea of some comparisons there. So if you think back to the last concert you were at, most likely you saw something like the picture you see on the screen here. Modern day speaker systems now have developed dramatically from what they were in the early 1900s and the mid 1900s to now what they call a speaker array. The speaker array that we're familiar with is it's very imposing, it's large, it usually hangs up above the stage or on sound towers in the back, and it is designed for a couple of things. Number one, it utilizes speaker drivers that are specifically designed for a frequency range. For example, your tweeters, your mid-range, and your woofers, so your treble, your mid-range, and your bass. In addition to that, it uses highly directional cabinets to direct that sound. One of the tests that sound audio engineers do is they want to direct that sound to a very specific point in the arena. So they'll actually take an audio test in front of the speaker and then step to the side of the speaker and see how much decibel drop you see. The better decibel drop that you see, the better directionality that cabinet has. Why do we care about that? Well, because in a speaker array system, the design is not to just throw sound everywhere. The design is to specifically direct sound to a particular area, control that sound, and make sure that it is evenly distributed using multiple arrays in order to provide a similar sound experience to everyone in the crowd. That is why you can see the point number 3 here is that the speaker arrays, modern day speaker arrays, actually conform to the physical venue that they're deployed in. So many of them have a curve like you can see on the picture on the left, which is used in order to direct. For example, the top speakers are directed at the top of a seating bowl, whereas the bottom speakers would be directed towards the people in the front or the people on the floor. And the picture below, you can see a music festival, where in a music festival you don't have the high-rise seats that you might in a indoor venue or in a stadium, and so you have more of a flat array where it's just directed almost in the same direction. There's some arc to it, but not nearly as much. And if you have attended an indoor venue recently, any NBA, NHL type of event, you'll notice if you look at the speaker arrays, look up, and you'll notice that many of these speaker arrays are actually pointing up from the scoreboard, because now many times the scoreboard is below where the top seats are. And so these speaker arrays are used directionally in order to point that sound exactly where it needs to go. So how in the world does this relate to Wi-Fi? You didn't come here to learn about sound, you came here to learn about Wi-Fi. Well, let's establish that and go through a couple of things that where audio and Wi-Fi are very similar. First is a simple thing that we do every day without even knowing about it, and that is analog to digital conversion. We have digital to analog and analog to digital that happens every day in our modern world. If you think about it in the world of audio and sound, you have an analog signal coming from a voice, from an artist's mouth, or from an instrument, and that is converted from an analog signal into a digital signal using digital sound processors, soundboards, amplifiers, etc. And then that signal is then converted again back to analog. That analog then is broadcast over a speaker where the fan then hears that sound and processes it as an analog signal. The exact same thing happens in Wi-Fi. If you think about it, it's not quite as linear. It actually is more circular. But if you think about the analog signal is the Wi-Fi signal that originates from either the access point, the base station, or from the client device. So when you pick up your iPhone and you select, I want to go to Google, there's a digital signal in there that's converted to analog. It's broadcast out over an antenna, where it's then received by an antenna on a base station and then converted into a digital signal on the access point or the motherboard. That happens literally hundreds, thousands, and sometimes millions of times per second in order to provide you the type of throughput that you are used to nowadays. Now, one thing that's interesting here that we won't spend a lot of time on, but it's very unique in what Everest has done with our new Wi-Fi system, is that where everyone in the Wi-Fi world has spent a lot of time focusing on the digital side. If you look at many of the enterprise vendors nowadays, they have a lot of features that relate to the software. They have a lot of features that relate to how they make Wi-Fi work better based on signal timing. They work better on excuse me, on different specifications like 802.11ax, AC. Those are all digital type of functions. We looked at it as a little bit differently. We spent time, energy, and money in developing a better analog side. Now, why did we do that? Well, because if you think about a modern day concert, for example, you don't use the little microphone that you buy down at the local five and dime and a speaker that you use to broadcast in your living room. No, you have high-end speakers and high-end amplifiers and high-end microphones that will give you the best frequency response to give you the most premium sound available. If you think about the last Wi-Fi system that you deployed, think about how much time and energy you spent on choosing an access point versus choosing a antenna. In many cases, the antenna is kind of an afterthought. You might have a directional antenna, you might have an omnidirectional antenna, but is one directional antenna different from another directional antenna? If I get a 30-degree panel from brand X, is it the same as a 30-degree panel from brand Y? In many cases, that is the case. So we spend a lot of time and energy developing high-end analog solutions, meaning antennas, Wi-Fi antennas, in order to give you a premium experience, which increases the overall system capabilities. In addition to that, this is one place where we're very unique. If you think about a speaker and relate that to a Wi-Fi antenna, just like in the old days, if you think about the original PA system, they had one speaker, a 34-inch audio driver, that provided the frequency response for your bass, your mid-range, and your treble. That's like your standard audio today. The picture on the left actually shows a pretty popular viral image that went around showing a fake tweeter that was installed on a computer speaker. And we've all seen that before. Many of the low-end audio systems that we use have just a single audio driver, just a mid-range designed to give you enough of an audio response in the middle of the frequency range, but doesn't really give you great highs or great lows. Versus a premium audio system, we all know it from our cars or from a nice audio system in our home. We'll have high range treble sound coming from your tweeters, a responsive mid-range driver that provides that mid-range frequency, and then low range frequency that's delivered by the large subwoofer. We compare that to Wi-Fi and think about, in this case, just 5 gigahertz, because 5 gigahertz is the most commonly used frequencies nowadays. And think about your standard Wi-Fi. In most cases, your standard Wi-Fi, which in 802.11 AC extends from your 5.1 gigahertz all the way up to 5.8, 5.9 gigahertz. In most cases, there's one antenna that the manufacturer recommends for that entire range. Very, very similar to the standard audio that you see on the left. We have one audio driver covering the entire frequency range, and in standard Wi-Fi, we have one antenna that's designed to cover the entire frequency range. With Everest, we actually developed and patented specific antennas for specific frequencies. So we actually have, very similar to a tweeter, a mid-range, and a woofer, we have a low frequency, a mid frequency, and a high frequency antenna that we put in all of our high density and premium Wi-Fi products. This gives you a little bit better definition here. If you look at closer at the 5 gigahertz spectrum that is allocated in North America, for example, we have Uni 1, Uni 2, and Uni 3, just to simplify things. In Uni 1, we actually have a radio specifically designed to deliver the best frequency response, and antennas designed for the best frequency response in just those channels. That we duplicate that and extend that to Uni 2 and Uni 3. So we are actually very proud of the fact that you can't take one radio and utilize it in multiple ranges. Why are we proud of that fact? Because you wouldn't do that with a audio system, and in order to get the best response, you shouldn't do that in a Wi-Fi system either. And most standard Wi-Fi systems don't do that these days. They give you the wide range over one antenna and one radio set. Now, this to me is where I really wanted to get to, which is, the audio evolution versus the Wi-Fi evolution. I've been in Wi-Fi, for almost 20 years now. The 802.11 spec was originally ratified in the late 90s, and I got into Wi-Fi just after the 2000s. And so I've seen a lot of the evolution, and it's funny that it has evolved very, very similar to the way that audio has. If you think about the original systems that we talked about, they were low-powered, single-speaker systems, like in the early 1900s, with the need for more sound. In the 50s and 60s, more amplifiers were used, more speakers were used. They started to, at that point, divide the signal among different audio drivers. You have a tweeter, a mid-range, and a bass. But they still, you can actually see it on the bottom left here, they still, in order to deliver that additional sound, would not worry about direction, but more about the actual sound itself, the power of the sound with the amplifier, and the number of speakers. And so it was very little directionality. So you can see this is a concert from the 1960s where they just literally stacked speakers on a tower to the left of the stage. And all that really did was blast the sound out there. Now, your modern day concerts, your modern day audio systems, to provide the cleanest sound possible and to reduce the amount of noise, will use highly engineered speaker arrays that were developed to provide that highly directional and low noise audio system. That's the way that modern day concerts can sound better, sound cleaner, without being louder than the old concerts that you used to go to. So we actually have less decibels that we're hearing nowadays in modern day concerts than a lot of the old school concerts that you'd go to. If you compare that to Wi-Fi, you can actually see that evolution where audio took almost 100 years to evolve just those 4 steps. Wi-Fi has done a very similar thing in the last 20 years. So the original system, if you think about the early 2000s, Wi-Fi was really designed for low power. It was not designed to cover large areas. It was designed to cover offices only in an omnidirectional type of area. With a need for greater coverage area, we all started at one point, if you've been in the industry long enough, selling power amplifiers. We took a 25 milliwatt access point and slapped a 500 milliwatt or a 1,000 milliwatt amplifier on there in order to increase that coverage area. All that really did was increase the signal level coming from the access point, but it also increased the noise, and it did very little for the client side. So the client wasn't able to communicate any better. All he did was see a better signal from the access point, but the communication back from the client was actually hurt in that case. The evolution from there was that more APs were utilized, with limited directionality. If you look at many modern high-density deployments, you don't have a lot of directional antennas. In most cases, you have multiple access points that are turned down very, very low and utilize omnidirectional antennas. So covering a conference center, a stadium, an arena, you a lot of times have omnidirectional antennas that are just turned down very low to cover a microcell, a small area, and have multiple APs in that area in order to provide that coverage and capacity that you need. And then we look at Everest as we're the next evolution of Wi-Fi, in that in order to provide that next step to follow the audio evolution, we actually patented antenna arrays that provide highly directional, low noise Wi-Fi. Now, I'm not saying that we were the ones that patented the original antenna arrays. Many manufacturers use antenna arrays, but our antenna arrays are very, very different from anyone else's, and they're not interchangeable with other vendors. So let's jump into that a little bit and look at the difference. Everest Networks has been around now for about 4 years and has partnered with Panasonic. Panasonic has helped us bring these products to the marketplace. And our HD Wi-Fi, we call it our high density or high def Wi-Fi. Our premium Wi-Fi means that we have products that have 4 concurrent radios per AP, and in some cases more. We have software steerable antennas. So from your software, you can move the signal with the touch of a button. In addition to that, we use advanced military spec hardware in order to reduce interference. So we concentrate, as I mentioned before, we take a lot of time and spend a lot of money on those antennas to make sure that that analog side of the analog to digital conversion is as clean as possible. And then we actually have artificial intelligence that helps direct users from radios and antennas, and also antenna beams, in order to provide the most optimal coverage for you in a crowded environment. This gives you a little bit better rundown of the entire Everest lineup. On the left-hand side, you'll see our highly directional, our high-end premium Wi-Fi devices that go from very directional, from a 15 by 15 degree beam, and with the ability to change and modify those antenna patterns, you can actually go to 110 by 30. And each one of these HD Wi-Fi devices has the ability, as you can see, to change your antenna pattern. We call it pan and tilt, just like you would a camera. All of the outdoor devices that we have designed are designed to be outdoor permanently. They're IP67 rated. They all have at least 3 5 gig radios and 1 2.4 gig radio, and are designed to give you, again, the most optimal Wi-Fi experience that you can have. Now, of course, you're not going to use this everywhere. In most cases, you obviously have room and places where you need just a standard Wi-Fi. You go into an office or a small conference room, there's no need to put the type of technology in there that you would in a concert arena, for example. So we do also have standard Wi-Fi devices that are your lower powered, your standard 3 and 5 dBi antenna gain omnidirectional type of access points. Now let's look at the 4 radios per access point, what we mean by that and why we do that. Your standard Wi-Fi will have, in most cases, 1 5 gigahertz radio and 1 2.4 gigahertz radio. It's usually called a dual band Wi-Fi. There are some manufacturers that offer a tri-band. They might have 2 5 gigahertz and 1.4, for example. We're the only vendor on the market right now that offers 3 5 gigahertz radios and 1 2.4 gigahertz radios. And in some of our models, we also have a BLE or Bluetooth Low Energy radio for IoT. Each one of these radios, the 5 gig radios and the 2.4, all are 100% independent when it comes to control. You can control the SSID that's broadcast, the transmit power, in most cases, the ability to steer that antenna as well, and everything that you would normally control with a standard AP, you can control down to the radio level as well. What this has allowed us to do, if you look at a large deployment, and perhaps not everyone on this call has done large deployment like this or has one of these in the future, but if you start to look at large scale comparisons, one of the advantages that Everest brings to the table is because we were able to provide three 5 gig radios and one 2.4 gig radio in one radio or one access point body. We were able to actually go into a large high density environment and provide you a much more economic overall project cost. If you look at some other vendors and how they go into a stadium or an arena, in most cases, you have hundreds or thousands of access points that you're deploying in that microcell type of environment that we talked about, where a standard football, for example, stadium might have anywhere from 800 to 1,200 access points in a omnidirectional type of deployment. Well, the largest cost in that type of deployment is not the access point itself. It's the construction. It's the cost it takes in order to run a cable there, to drill a hole, to mount an antenna, to mount an access point. That costs much more than the access point itself. The access point is usually a third of the cost of the actual construction. So if you compare that to the Everest, with our highly directional antennas, with our ability to mount above and in a lot of cases behind the fan, there is no need to put that technology at the customer's feet or in the handrails, for example. So we are able to save a lot of money when it comes to construction. In most cases, you're spending more for the technology, as you would expect to do when you are buying a premium product. But because you're spending more, you're actually spending less on construction. In our case, usually it's about 2/3 of the cost of a project is the hardware, and about 1/3 is the construction, where that's usually flipped with other vendors. Now, omnidirectional versus directional antennas. Why do we care and talk so much about the omnidirectional versus directional antennas? Well, just like in sound, and how if you've got a low-end speaker that just allows sound to bleed everywhere, Wi-Fi and an omnidirectional versus directional antenna is the same thing. So in a standard Wi-Fi, most of your energy is wasted. Most of that energy is broadcast all over the place. Whereas the user itself might be standing right under the access point, most of the energy from that access point is being broadcast above or to the left or to the right. So the more directional your antenna can be, the better the Wi-Fi experience is going to be. If we look at the Everest solution and some of our highly directional antennas that are used all the time all over the world now in sporting and concert events, for example, our most popular model is the 1004 NRE. This gives you 4 radios with a narrow beam coverage. Starts at 30 by 30 degrees and can adjust all the way up to 60 by 30 with multiple variations in between. And what you're seeing on the right-hand side is an actual deployment where, similar to the speaker array that you see in a concert environment, where you actually have a curve to the speakers, we actually implement the same type of technology utilizing our steerable antennas. Our steerable antennas allow us to cover with one access point the front rows of a seating section, the middle rows of a seating section, and then the back rows of a seating section. The only other way to do that with any other project or product is to go in and either install 3 independent directional antennas, or to put 3 independent access points under the seats in order to get that type of coverage area. So we provide that microcell coverage all from 1 AP up to 150 feet away from the location. Here's another stadium design that we've done where we have more of a top-down, utilizing our ultra narrow. We've been able to provide service up to 300 feet to large crowds. And again, utilizing, you can see on the right-hand side, there's 3 APs there, and each one of those 3 APs has 3 beams, independent beams that are steered and covering low, mid, and upper section. Now, of course, you can say a lot of things, but what does it really look like when you put that down and actually measure it? So here's what you see with a predictive survey with our antenna technology when we look at one of these designs. On the left-hand side, you can see the lower portion of the seating section with just the lower antennas turned on, and in the middle you see an upper part of the seating section with just the upper antennas turned on. What you're seeing here is something that we're extremely proud of, and that is very similar to what we talked about earlier. When an audio engineer tests a speaker cabinet, he'll walk to the side of it and see how much loss there is, and the more loss he has, the better. Same thing with our antennas. When you broadcast with an antenna, a directional antenna, As you walk away from the intended coverage area, the faster that signal drops off, the better. That means that you have less signal dispersion. That means that you have less noise that can cause interference on both the client and the access point, which results in faster throughput. And then on the right, you actually see when you combine that all together and put that into a large environment with multiple access points, you see we have an entire stadium coverage with our high-end HD Wi-Fi products. Now, I won't spend a lot of time here, but just want to give you a quick look at what the back-end control system looks like. We do have a controller system that controls everything. It is a web-based single pane of glass in order to control all of your Wi-Fi. It provides advanced client analytics, detailed dashboard, where you can do individual radio configuration, or you can do bulk configuration. If you need to update an SSID on 500 APs, it's a click of a button. If you need to do it on an individual radio, again, click of a button. It has automatic event report generation. So if you have an event or a time period that you want to automatically create a report for, it automatically does that for you. In addition to that, we're very proud of our mapping module. In our mapping module, we is part of the standard software. You can drag and drop your access points onto a uploaded map that you can provide, where it will provide for you RF coverage. It will provide you roaming heat maps. It will provide multiple views. It will provide you throughput heat maps, as well as client account heat maps in order for you to identify and troubleshoot hotspot or trouble areas. And lastly, this is one of the new features that we have implemented in our most recent software release, and that's client tracking. So in this case, you can track a client's motion from AP to AP, and you can actually historically pick a MAC address on the system and watch it historically move throughout your Wi-Fi network and see it go from access point to access point. Why do we care about this? Well, this becomes a very valuable troubleshooting tool when you're looking at the aim and the directionality of antennas. If you have an antenna that's supposed to be pointing straight down at a seating section, for example, but it somehow got moved because an installer or somebody else came and bumped it, well, you'll see that a client won't actually move from one AP to another. They'll actually jump maybe across the arena. And that's a good indication that you've got an access point or an antenna that is out of alignment. So with that, that is all I have prepared. I hope it's been interesting and somewhat fun. And we hope that this is giving you a little bit more to think about when it comes to Wi-Fi. And my message would be do what the pros have done and ditch the standard Wi-Fi and upgrade to Everest HD Wi-Fi today. So thank you very much for your time. And I have got my contact information on the screen. Please feel free to reach out at any time. Would love to talk with anyone that would like to reach out and coordinate with any of the Microcom account reps in order to work to get you a solution that might be used in your environment. Thank you.
Thank you, Ryan. We enjoyed that very, very much. I do have a couple questions for you, if you don't mind.
Of course.
Terrific. Let me get started here with the first one. Does the equipment used within these shows cause interference on the network?
Does the equipment used in these shows cause interference on the network?
Correct.
That is kind of a very vague question, so I will try to answer it the best that I can, and if there is a follow-up question, I'd be glad to take that as well. So all of the equipment that we offer is standard 802.11n and 802.11 AC, meaning that it utilizes the open frequencies of 2.4 gigahertz and 5 gigahertz. So yes, when it comes to a concert environment, in a lot of cases, we are going around and actually coordinating with other providers in the area and making sure that we don't interfere with one another. In a lot of cases, these shows have wireless microphones, for example, but in most cases, those are actually working on a lower frequency. In a lot of cases, the 400 range or the 700 megahertz range. And so one of the things that we're extremely proud of, actually, and why we really have seen Everest become the standard for a lot of these events that we get literally picked at for multiple times a month to go install in multiple environments like this, is because of our directional antennas, because of the way that we control our beams, we are not susceptible to the type of interference that other access points would be. And that's not only on the receive end, we don't hear that interference from other devices, but we also don't provide interference because we're broadcasting at a very, very directional level, and so we're not spreading and shooting frequency everywhere. What we found is that in most cases, we're actually turning down. We've got some instances where we've been shooting a 5 gigahertz signal from a catwalk that's 90 feet in the air, and we've had to turn the power down to 8 to 10 dB just to give the best throughput possible. It's because of the directionality and the high quality of our antennas. So hopefully that answers that question for you.
Excellent. Thank you very much, Ryan. Next question here for you. When installing your products at Coachella, would it be for the vendors and musicians or for the patrons?
We have multiple partners that utilize our product in multiple festivals and venues, and so each one's a little bit different. It so happens that at Coachella, where our stuff is deployed, it is not for concessions. They have their own in-house system that they do. It's also not for back of house. Back of house, they have their own standard Wi-Fi because they're really not trying to provide Wi-Fi for a large crowd. In this case, we are providing Wi-Fi for the VIP sections. Coachella is a huge festival, and they have some high-end VIP sections that are extremely crowded and cost a lot of money. And so our product is being used to provide at the VIP sections. In other venues, like for example, the one that you see here, this is actually the Made in America festival that happens in Philadelphia every year. And in this case, we were actually providing the crowd facing coverage. So we're sitting on the left-hand side, that's the main stage. On the right-hand side, that's the front of house delay tower, and we have multiple APs covering the entire crowd. So we have done, again, both back of house, front of house, crowd, VIP sections. It just depends on what the customer needs.
Excellent. Thank you very much, Ryan. Next question here for you. The HD Wi-Fi, the max antenna gain is 21 dBi. Is there room for improvement or hardware upgrades?
No, at this point, we are always developing and always changing. We have a next generation of antennas and products that we're developing, but the limitation right now, of course, is the FCC regulation. So everyone is well, not just FCC, but regulatory regulation. So every regulatory domain has their regulations and the specific EIRP output. And so at the 21 dB, that is maximizing the output of the radio and then the antenna itself. So at this point, we don't have the ability to go greater than that, but we are looking for futures to have more directional antennas that would increase that gain.
Thank you very much. Next question here for you. How many SSIDs can be made, and can bandwidth be controlled individually per SSID on the devices?
That's a great question. So the way that our system works is because the controller manages the configuration. The controller can theoretically have unlimited SSIDs. So you create a network in our controller, and it can theoretically store unlimited. It's a software base that's only limited by the hardware that you put it on. Of course, that doesn't translate into what you'd want to put on an access point. On the access point itself, each individual radio, again, think about each access point has 4 radios. Each individual radio can have up to 16. So if you do the math there, you're 16 times 4. So you can have over 50 SSIDs on one access point. Now, that's not recommended. We would not recommend that. But that is what you could do. So you could identify and broadcast up to 16 SSIDs per radio. Manufacturer's recommendation would be no more than 4 per radio.
Excellent. Thank you, Ryan. Next question here for you. On the image example with the stadium, for the 1004NRE. How are these powered?
Excellent question. All of our products right now are powered utilizing standard power over Ethernet. So we can accept 802.3 AF, 802.3 AT, and 802.3 BT. In this case, our high-end products require two in order to power up all of the radios. So we have actually two 802.3 AT or Wi-Fi plus, PoE plus inputs. Our low-end devices, our standard Wi-Fi, are single PoE input.
Thank you very much, Ryan. Next question here for you. Can you remotely access the wireless management system even if you're not connected to the network?
Great question. The wireless management system is a software piece that is free to download and free to install wherever you want to. So you can actually go to everestnetworks.com right now and download that. You can install it in the cloud. You can install it on a local PC, or you can install it in a cloud-based PC, and you can forward and point the access points to that wireless management system. So that means that I can't answer that definitively because it will depend on how you as a network engineer set that up. The short answer is yes, you can set it up so that it is a cloud-based instance that sits on Amazon, for example, or a server of your own build, and you can access that control system outside of the local firewall and still control those access points remotely from a cloud-based software instance.
Thank you very much, Ryan. A couple more questions here for you. Next one is, can client tracking be shut off?
Can client tracking be shut off? I'm assuming they're referring to the client location tracking. And this client location tracking there's two levels to it. So the client location tracking is not something that we can shut off. It is something that we naturally track in our system because we will actually know when a client moves from one access point to another. That doesn't add any overhead to the system. It doesn't add any throughput loss because we're naturally tracking when a MAC address moves from one of our APs to another, utilizing standard specifications like 802.11v and 802.11k to share neighbor information and move clients from one to another. So that happens all on the back end. The display of your client tracking is something that an admin has to purposefully do. So at this point, you purposefully have to go in and specify a MAC address, and then you can track where that client is. And then you can actually take it to a third level, which is using third-party analytics. We can actually get more detailed client tracking. So I know that's not where the customer or the question is going. The customer is looking to turn off the client analytics. Then the honest answer is we can talk about a special build, for example, where you don't have the ability to display it, but we naturally will track it in our system as it is. And that just so you know, that data is purged after 3 days, that detailed data.
Thank you very much, Ryan. I've got a comment here. One of our audience members says that they haven't seen a comparison like this before, and what a great analogy and excellent information. So I wanted to pass that on.
Wonderful, thanks.
You're welcome. Last question here. Is there a demo link for controller access?
Yes, if you go to everestnetworks.com, I would pull up my browser, but I hate to do that because you never know, if the internet's going to work when you're in a live demonstration. But if you go to everestnetworks.com, which is displayed on the screen here, and select the WMS option, if you select products and then WMS, there is a live demo that you can log in and see a software instance that we have running in the cloud. And then, as I mentioned earlier, there is also on that website, you can sign up for the support and download section just by providing an email and password, and that allows you to download the software and install it yourself. It's designed to be a virtual machine install. So we have an ISO file there that you can download and install and then run on your own. And like I say, as I mentioned earlier, and I didn't spend a lot of time on it, the way our system works is that the software is free. There is no licensing or support fees. And so the only thing that you're paying for is the access point itself. So you can download and install that software and play with it as much as you like and install an access point when you buy one.
Ryan, thank you so much for all of that information and for answering all of our questions today. And also thank you to everyone attending today's webinar. If anyone has any further questions, please feel free to contact us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown here today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel so you can view it again. Ryan, appreciate your time today. Wonderful talking to you. And until next time, thank you very much.
Excellent. Thank you very much, Julie. Have a good day.
Bye-bye now.